the AA. What you're probably not aware of is that 10 years ago, Kas was an intermediate school union master. At that time, we were just staggering into the computer age. Kas, I remember, was extremely excited because we had an Intergraph workstation that was on loan to us from Intergraph, and we were up to no less than version 2 of MicroStation at the time. We had some wonderful computers that ran all of them.
So if you just want to see this.
Hard drives that could even store as much as 20 megabytes. That was including all the programs and all the work that was being done. It was quite an exciting time. Kas is an architect. He operates in that area that's between architecture and sculpture and computer programming. I did, maybe to embarrass him,
Let's first check if someone is hearing me. Is that okay? Yeah? Okay. I first would like to introduce some people who are working with me in my office. That's at the first place, it's Ilona L. She's a visual artist. Her work is very much based on intuitive gestures. And Menno Rubbens, who is an architect programmer and adds programming to the architectural field. So if you add my profession, I was educated as an architect, visual artist and the programmer together. If you mix that together, then wonderful things can happen. My architecture, well, I wanted to leave architecture as seen in a traditional way. I didn't want doors, I didn't want windows, I didn't want traditional elements stacked upon each other. I was much more into the idea of making sculptures, and since a number of years, since 3-4 years, into the idea of making sculptures which are intelligent and which behave themselves, which respond to the visitor, which are talking back to the people. I've given this lecture a name, Parametric Behaviour. The behavior, behavior means that the building, like I said, will be active. It's not a static thing. It's not static material stacked upon each other. The building is programmed. It sucks up data from its environment and works upon those data and throws images back, and people who walk into the buildings can respond to those images and communicate with the building. That's an idea we are working on now and have realized in some versions. And the parametric side of this title means that we are working with databases. We are working with numbers, shifting numbers, and we let the computer calculate many possibilities of which we can choose freely, of which we can choose intuitively as well. And that's in the end maybe the meaning of our whole enterprise. We wanted to relate intuition with logic. We wanted to relate quick gestures, quick thoughts, with reason, with calculation. And well, we found that the only instrument we could do this was the computer. First, I want to show some simpler projects, housing project, where Ilona and I started to think about the fusion of art and architecture, where we started to think about working at the same scale. We didn't want to have an artist working, you can have the lights dimmed if we didn't want art to be something very small in relation to architecture, which was very big. We want to think about the same budget. We want to think about the same scale. The first thing we did together was this project, 6 patio houses in The Hague in Holland. Well, you don't see the houses. And that was intentionally done, of course. We didn't want you to show the doors or the entrances of the houses. What we did is made one huge screen wrapped around the whole building, a transparent screen, and on that transparent screen there was painted this dazzle painting. What we actually did, we emptied the traditional architecture of its traditional elements and then put new image onto that. In the course of this lecture you will see that what starts with painting will develop into reliefs, 2.5D will turn into 3D objects, so that art and architecture is active in the volumes themselves and not as some projected image or a wrapped around image like this here. So the way the people who live in this house communicate with the world, I can use this pointer, if I can find it, here. Number 109, that's the house, the number of the house. And here you have an intercom, and there, here, hardly visible, there's for the postman, the slit in the facade for the postman. These elements are sliding doors, 5 meters wide, 3 meters high, and you can open it entirely so that you have a large communication window to the outside world. But you can also close it, and many people choose to close it. Next project, next dazzle painting we did was this project, where it's a project about 9 houses in a row. The bottom, the basement really, is made of glass houses, and on top of that a large bar containing the sleeping rooms, and this bar was 3-dimensionally wrapped around with this dazzle painting. And this dazzle painting originated in a computer drawing, in computer sketch. These projects we started at the end of the 80s and realized in the beginning of the 90s. We wanted to use the computer as an instrument for the intuition, as an instrument to sketch without prefabricated thoughts. That was the most important idea at that time, that we didn't want to have a project in our head and then start to draw the project. We wanted to start to draw immediately at the very first beginning, so that you react on your sketches like you do when you sketch on paper. By the way, the project you see here is a project the 3 of us did, myself, Ilona and Menno Rubbens, called Sculpture City, where these ideas were practiced in a manifestation in which was an exhibition, a lecture evening with Marcus Novak and Stefan Perella, in which was a workshop where we made with milling robots foam models, where we had the 3-dimensional model directly related to a physical model by milling foam foam, pieces of foam. You may catch some of these sometime. And we made a huge model in the gallery. From within, we projected a virtual environment, the design environment, which the model cloud 010 was part of. These are the foam models. You might catch one of these. The idea was that this model was a building about 60 meters high and had an electronic facade. Electronic facade which was ever changing and which was activated by the passengers. This is the milling robot. Okay, continue here. Next project was where we started to turn this dazzle painting idea into slightly more three-dimensional shapes. So we made this brick base on top of which Ilona placed these colorful dancing facades. And that was really made in the same way with quick sketches, and then we took a long stretch of them and wrapped it around this little container on top of the base. And if you look carefully, it's not easy to understand where the corner is of these boxes, because the colors go around the corner. Sometimes it stops at the corner. So here we start to turn our cooperation more into the 3D environments. The next step we did was this artist studio, where we folded the roof using the same way of sketching in digital space. And we just fix a certain arrangement, a certain configuration, and then we say, okay, we just make it. We pick up the coordinates, we give the coordinates to the steel manufacturer, and he just makes it. Next step. I start with some smaller project, but because it explains a lot how we work, have worked, and intend to work. This is the folded volume. The idea was back in '99, where we had this manifestation, the synthetic dimension, in Museum de Zonnehof, a building done by Rietveld. You might recognize it. The idea was to jump into that digital space with our work, and there were also other works at that exhibition which were exemplary of that attitude. We also had, for example, a big Frank Stella painting. Frank Stella I was particularly fond of at that time because his gestures were gestures in space. He exploded the painting from the wall, it exploded into space. Our work is not that baroque as Frank Stella's work is, but it is the same idea. We stretch elastic 3D models, we pick up coordinates, and we pull onto this point. We pull them away. We kneaded them, and we can do anything really with all these points. And it's amazing how complex it looks suddenly when you use more than the 8 points a simple container uses to define its shape. Here we use only 16 points really, but they are arranged differently than the 8 points from the parallelepipedon. And there the volume folds. Onto the volume we projected the originating sketch in a flat version. And here you see a close-up of the skin of the object. A skin which is a stretched skin really, made of PVC and spans along a wooden frame. Another close-up of one of those foam models. we made in the workshop. This is the early sketch we made for the water pavilion I will show you later. Another foam model. So again, how we did this in the workshop was we modeled in 3D Studio, we shaped, we fitted the volumes, into shapes. Well, that's how you can work in 3D Studio. We translated the model into the milling path of the milling machine, and 15 minutes later, after you made the model, you had this physical model in your hand. This particular one was done by the Hungarian artist Károly Tóth. This particular one was made by Markus Novak. This is one of our clouds. And we imagined those objects to be large buildings. This is the model, already 3 meters high. And this is how we imagined them to fit into the urban landscape, how they would fit into the landscape, the urban scape of Rotterdam. And we were thinking about buildings like being parallel to each other. Not buildings, one building at the side of each other, at the other building, but you have this in mind, that building exists, you just merge these two worlds, and eventually you can make one of them, and you can make the other one, and some kind of battle will emerge, and well, you just see which one is the strongest. I think that's the way a city grows, really. We also put little pieces of chewing gum on top of buildings. It's really fun how this material is elastic, and it really feels like chewing gum. And you can make it as big, you can pump it up, you can make it lean, you can make it bulky, you can make it voluptuous. You can do anything, and you can calculate. That's the wonderful thing. If you work digitally, you don't have only an image, you don't have a photo montage, but you have a calculated volume. You know exactly how much cubic meter is in there. And you can also send your data to construction engineers, and they can calculate it further. And they can hang at facades, they can float in the water, or they can turn into a bandstand. That's a project we did this summer and is realized now. It's an art commission. It's a bandstand to be placed in a park. You see, this is the formula, really. It's a sketch. That's the side on top. You have an oak leaf, you have a park, you have a sketch, and you turn that sketch into a 3D model. And of course you can imagine how it looks like in the sides. And then to explain how we do that, how we realize that from that 3D model, we send our data mostly on floppy or through the net to the construction engineers. They need only a few data, really, describing the curves, describing the fins, and they can calculate what thickness these fins should have. And of course we decided how this should be, how thick this should be, and they constructed it as a ship, really, and as one single volume, as one single material. It's all steel, and they constructed the whole thing in the workshop of that steel constructor. Welded it together so that it's a kind of sandwich construction. Then they cut it in 3 pieces, transported it to the sites, and welded it together again at the sides in 3 pieces. And you can imagine the same method for much larger buildings. And we actually did that in the case of the water pavilion. After the steel construction was placed, we sprayed a green rubber skin. So it feels like this, and the construction is real and tangible. And then the skin is 2 millimeters thick, so it has some acoustic values for the bandstand. So you could imagine yourself like him here, standing there and playing the trumpet. So it will be opened soon. We'll make pictures of that. But at the same time, it is when people are not playing there, it's a sculpture, and that's the idea. We don't want to make buildings or sculptures which present their function. You should not read their function. You should read it just as an image, as a sculpture, and it should trigger your imagination to think about many things, but not about its function. But still it functions, and that's the thing I'm very much interested in, to make things which doesn't look like they're functioning. They look like being sculptures or just being there for some reason, but they have this hidden agenda of functioning after the program which was requested, because we have to satisfy the client as well. I think it's wise to, we can just keep this running for a few minutes before starting the first videotape. The idea of when we go over to larger projects, the idea is very much to create bodies in space, bodies in time later, bodies in motion even. So we're not so much thinking about repetition. We are thinking about this one single body, which is this is different cuts. When you cut your own body, you have these different sections, and we don't design the sections, but we design the bodies, and after that you can make sections and send the sections to other people whom you have to communicate in the building process. So that's a different approach. We actually only use 3D models. This is a housing project we did a few years ago, which was built as a dike, one large body of clay in Groningen, 200 meters long, containing 30 houses. And these are the clay bodies, reinforced clay, which are put all in between the houses, and together, if you see, I don't have that picture with me, but if you see them together, you actually see one big dike. You don't see houses. If you come closer, you see a house like this. And it's a changing view of grass and glass. That's only the two materials we have. To me, it seems very light, those pictures. Maybe they can be a little bit darker, because this roof should be black. The way we shaped our volumes was very much by Boolean operations, using solids and volumes rather than starting off as lines and planes. So we are not so really interested in folding planes really, but much more in folding volumes and operate volumes in a Boolean fashion. And then by these operations you can calculate any shape really. What we did here was we had an oval shape extruded in one direction, say the X direction. We had a triangular shape extruded in the Y direction, and we intersected them. So if you know about 3D Studio, you know, or AutoCAD, AME module, you know about these operations. You can also join them, and you can also subtract them. So here we calculated what they had in common, these two bodies. And this project, which is a garbage transfer station, where people bring their garbage, it's worked upon, it's rearranged, and then they drive it to a mountain, which is to the right, a mountain which is much larger than the building itself, and the building is 150 meters. Here we shaped this body after some requirements of the clients. We needed this big hall, and we needed an office, and we needed some additional spaces, but we didn't want to make separate volumes on that site. We wanted to make one body, one volume, and we decided to turn that hall into a much smaller thing at its front end. So then we have this body which ever changes shape. Each section becomes much smaller until it reaches its nose here to the left. So here we have this body with a smart head. We could, it's still rather light, the image. With this, is there someone there to operate on? Can it be a little bit darker, these images? No? It's too much lumen. It's too good project. An intelligent head, a piece joining the head and the trunk part. The lines you see here, I try to use this pointer here. These lines are for ventilation and for bringing up the natural sunlight in the large hall and keeping the rain out. At the other side, the hall is open, so it really is a very huge pumped up skin, really, pumped up volume. This is aluminum skin, which from the street doesn't look like a garbage transfer station. It looks like a huge object softly landed at the site. And there you see this detail that we rounded off the building where it reaches the ground so that it's landing softly, and we embedded it into the site in a concrete floor, which was also using gentle slopes instead of hard edge. This is the inside where these huge trucks carry the dirt to the mountain. At the right side, this hall is open. At the left side, you saw it before. And here you see how the landscape, oh, where's my pointer? Here where the landscape gently comes into this gutter, which is 4 meters below ground floor level. I compared this attitude towards architecture, towards making bodies, with industrial objects as well. You very easily talk in biological terms, but that's not really my aim. It shouldn't look like a natural body. It's a body of its own, and it has some parallels just as much to industrial objects as it has to biological bodies. So take this car, for example. You have this motor, which is very compact, and you have this place where the 4 passengers sit, and if you take the sections, you have it very condensed and small, and it gets larger to house the 4 inhabitants, and then it goes slightly, gets slightly smaller towards the end again. And it uses these fluid lines It's not a body like the traditional car with the base and the top, the two box model. It's really the one box model, which is much more interesting. I think we could start tape number 3 now and change this one to video. After having practiced in a few projects this idea about making bodies, working, designing them in digital space with computers. Now this is the first tape, it's not the one I meant. Rather the third tape, it says AA3 on it. Then you work with computers and you work with these, this calculating speed of the computer, and you run into programs which can make bodies intelligent, which you can start to program bodies. And that's what we made a start with this building, which from the outside is the body, the black body. Many people call it a whale. I wouldn't do that. It's something like a speedboat as well. But anyway, it's stranded. This is the sea, it's salt, and the level of the sea rises, goes up and down. And this body looks like being made in the sea and being stranded at this particular site, which is completely artificial. It's a man-made environment. It's cantilevering over the sea, 12 meters. Okay, I let this just run and explain the project here. This is how we started. We started to imagine. We were completely free to program the building ourselves. The only thing we knew is the budget, 2 million guilders, which was not much, and we knew a little bit about the size it had to be. But we started to imagine a program, and I think I think I'll just explain that. We started here with, this is the connection to the other part of the building, which is made by Nox architects, also from Rotterdam, which is the freshwater pavilion, and we did the saltwater part. And we also had one connection here. It's you could call it, you can see it in the pictures, kind of Apollo-Soyuz connection. One body completely different from the other body, but both spaceships. And then you go through a whirlpool. Then you come into a laboratory where you can experiment with water. That was the idea. Then you go into a sensorial space where all your senses are worked upon, and then you came to a hard nose, cool and edgy, crystalline, and this, which was shaped like an organ, was the place where you would exit the building. Well, we imagined in size and in program a few items like these. We arranged them in a way that you could walk through it, and we just made this kind of condom-like structure around it. It's just the skin wrapped around the program. Later we decided to do it differently. We wanted to be inside much more smoothly. We wanted to be one continuous space, not going from one room to the other room. So this is the model we ended up with, and what we really did is we took 8 lines along a path. We scaled them and we narrowed them. Here we cut it off. And this is another line. And so we have 8 lines going their own paths and coming together again in that node. Scene from the side. What we see in these renderings is not the outside but the inside, so it is rendered inside out. Now let me explain a few things here. It's a rather high body, 9 meters high. You have a space below, which is an underwater space, and which is actually flooded. Here sea level actually sometimes flooded. And then we have a floor which is like a giant wave, and on top of that, walking on that wave, this is the sensorial space. But now we walk from here, from the NOx building, we descend here in this underwater world, we climb up here, the nose, and we have here the vision outside. It's the only way where we can look outside the building. And walk this way and exit here, going out. And what you see here is a giant structure we call Hydra, which is a giant seaweed, a giant snake, say sea snake, made in which connects all places, all kind of places in that interior space, in that interior body. A few words on practice. We designed it as a 3D model, and it's really very clumsy to make that 3D model into a 2D model, but we had to do that because we had a rather traditional contractor. But a section like this is maybe true for this particular section, but if you dissect this body 10 centimeters farther from this, if you take another clipping, it looks different. And all angles are different. So a drawing like this doesn't help. You should make millions of drawings. I explain later how we could handle this by making spreadsheets of all the parameters and giving spreadsheets rather than drawings to the contractor. Seen from the other side, this piece is a spare piece of the giant dam which is built, the Paler Dam. I think it's a rather well-known structure. It's very huge. It's 50 of those cathedrals, and one of those pieces is really 50 meters high, 25 meters below sea level, 25 meters above sea level. And this building, our body, relates to these structures and relates to the cruising boat which crosses the sea. And so we have these three elements dancing together at this side. It's still under construction here. Now these stones here are removed, so the sea comes right up to here. First, a few words on the outside of the skin of the outside, and then we enter this body. We created this notion of skin earlier and made it here as an isolating skin. First we made a steel structure, and then we sprayed a thick layer of isolating foam on top of that, some kind of fat layer, and then on top of that we sprayed 2 millimeters polyurethane, which is very strong. I don't know if you know the material. It's very strong industrial coating, very thick, very elastic, and it can withhold any force really working upon that. This is how it looks from near. This is how it looks when you cut it. Here it starts to look like a whale. This is when you make a picture towards one of the fins. The fins which are starting with 0, then growing in size 10 centimeters and then diminishing again towards 0. Like the stabilizers on speedboats. Okay, here we start to get in, so I expect to get in here soon too. First the boat ride. Under its nose. The rendering again. The solid object. And the sweeping tail. Black body with sweeping tail. Done by the other architects. The panorama, the vision from inside. And here the other two dancers, the cruising boat and this spare piece of the dam. People leaving through this kind of airplane door. It's just a cutting into the skin. It's not a door really. It's not thought of as a door. It's just you take a knife, you cut three cuttings in the skin. And you make, I think it's called pivoting, you make these pivots up here. Sections through the body, steel structure, a space where the external skin can move. It can move freely around that steel structure. And in this hard shell, we have these elements. The floor, the bracing floor. Fresh air comes in here, in the floor, where it is assembled, and it transpires it out into the space and is sucked back again here. And here you see the first sketch of the Hydra. And this is the drawing, the construction drawing really, and how it is realized. The Hydra was thought of as an element which will contain later in the process, because it is a building which is not finished. It is a building in progress. Its behavior is in progress, where in a later stage more layers of information will be merged into. Now we started as a basic environment. We started with having light lines, glass fibers in that structure, and sound. When you walk along this structure, you hear sounds traveling with you along the 100 meters trajectory of this Hydra structure. And it sounds like burning somewhere. We can make any colors. We have robo-color light fixtures connected to these glass fibers. We can make any color. And the making of the color is related to a board unit which is programmed. I think that's the best way to say it. We can program completely any color in any sequence at any speed. But we get our data, and that's the exciting part, I guess, from the environment. It's not a fixed program, but it reprograms itself each time, in real time. Okay, back to the 3D model, how we modeled it. The Hydra is not in its definite form here, the rest is. This is how we made it. We made this whole wave-like floor and a large part of the steel construction, not here at the side, but in the place of the steel constructor. He made the whole thing, and just like the little sculpture I showed in the beginning, he cut it into pieces, shipped it over water to the sides, and welded it together at the side. So the whole idea is really really born with the sea in mind and constructed with the sea in mind. And that's also how we related to the other building, which was very much constructed from the land in mind. And then we had this connection between the land side and the sea side. And both sides of the building, the fresh water and the salt water, completes the water cycle. The water cycle, it starts with the glacier, melting into rivers, the river flattening out in the delta into the sea and into the lazy lines really of our body, evaporating again and turning into rain and snow and glacier again. That's the whole water cycle, which is explained as an experience in this building. An image of the floor under construction. And here you see the renderings back, which we made earlier, seen from the outside, but now it's real, and you're in the inside. So you see the same expression of the lines, which at the outside are the fins, the stabilizers of the body, and at the inside are the open spaces from which you can reach all equipment. So it's the open cuttings really in the inner skin. So the conception of this body is really having an outer skin, having an inner skin, and having, it's 1 meter about from inner to outer skin, having place for the construction in between. We can have sound on this one, if there is. One more feature here, water which is pressed out of the floor. It's a huge tunnel of water where you dive into the underwater world, under this water tunnel, which is also programmed, which is not continuously, but sometimes it's like the sea really. Yeah? It's the waves, where the surfers ride on, and goes back again, comes again. So all these cycles are programmed in this building. Cycles of sound, cycles of light, cycles of water. And they all mix together like a giant massage around you. Always colors are changing, colors are never the same. Programmed I think the program was called Mac. It's done on a Macintosh. What this program does, it takes data from a board unit, which is a maritime station. It picks up data from sensors in the sea about the amount of salt in the water, about the speed of the wind, about the sea level. All these data are imported and interpreted in a different way and converted into MIDI signals, and these MIDI signals go either to the mixing table for the sound or the mixing table for the lights. So what we have done, we have really programmed an emotive factor, I would call it, for the building, for the behavior of this body. And all these colors are derived or described by this program. If the wind is very fierce outside, if the sea level is very high, then the cycles inside go quicker. It starts to behave more emotional. This guy right there is playing the building as an instrument. It's the sensor board where he can control the light manually. He can override the program. When he presses at this sensor board, quite firmly to the right, for example, which he's doing right now there. One of the poles where the panorama is, here, glows up brightly in red. When he presses the other side of the sensor board, the other pole, the connection, the Soyuz Apollo connection, at that spot it glows up brightly in red. So that's the first beginning we have made for the exchange of visitor and environment. And the idea is that he can play the building. Here is the spot where he stood and did it. There's another spot here in this curve of the Hydra where you can play the virtual environment. The virtual environment is consists of 6 worlds we designed, and we can start the tape number 4 here without sound. 6 worlds which are projected through data projectors on parts of the wave-like floor on the inner skin, the transparent inner skin, and on other parts of the interior, in order to get this feeling of being immersed in these virtual worlds. And the visitors can play with these virtual worlds. They can navigate through them. So what in this video you see here, the pointer you see there is the navigator. You don't see it in reality though. But you can navigate through these morphing fields. You can navigate through water molecules. You can navigate around a blob, an ever-changing shape of water, and such. You can navigate through these amazing sea creatures we made. Same. The blob, ever-changing as a piece of chewing gum. So that is the really fascinating thing about virtual reality. You don't see it here, you see it here as a video, but it becomes amazing when it's real time, and when you experience it, it's as being calculated real time. That's the amazing thing about virtual reality, that you can make things alive, you can make things happen at the very moment, you can make things happen real time, and you can dive into that world. You can dive into this whirlpool, or in these slowly moving ice masses, or you can try to ride the water molecules which are flocking in space, which are like flocks of birds moving in space. You can see it in a moment here. And we designed 3 speeds in this environment. One speed which is very fast, one speed which is very close to your own speed, and another speed which is much slower than your own speed. And you can try to ride on some of them to catch up with the speeds. You were for a moment inside the blob, I guess. So just wait here for the water molecules. We could sell it as a screensaver maybe, but it's much more fun when it's really virtual. Then you can try to drive through that same space as the molecules are doing. If possible, I think it was possible, I would like to have the next tape, videotape, and the CD, the audio CD. At this very moment, we have this project going on, Parasite. It started a year ago in Rotterdam at RS96 festivals. It is an intelligent sculpture related to the physical side and to its website. And this Parasite, inflatable, is now on European tour. It has been in Helsinki, it has been in Dunaújváros in Hungary, near Budapest. It's now in Graz, in Austria. And in Graz, for example, it will change position every day. Each day it will replace itself, deflate, and inflate again on another spot, suck up new data, and these data are worked upon by a group of people working inside some kind of research group, which is continuously reprogramming the sounds you are hearing right now. So each day these sounds are reprogrammed in the program Super Collider, and it's shown each night. It plays its language, really. It's much more language we are thinking of than making a piece of music. It's constantly under pressure, the thing. So when you come in, you have this wind. We'll get inside here. The sound you hear right now is its first mumbling utterings, first day. It was set up in September in Rotterdam. It was rather cold at night, so it really felt like a polar expedition. Also with these sounds of blowing winds around you, cold winds. The sound was related to these light fixtures, especially dressing at night, when the sounds would go and flicker with the lights. And then it would look like this. This project was on its own website, on its Attila domain, its own domain, I should say. And people could work also through the site, through their sounds on the site. And we, from Rotterdam, can work with other people in those other towns, in Helsinki, in Graz, through the website. That's what we are doing this week. I think we just leave this video running and tell a few details about parametric design before we go over to the last piece of this lecture, where we incorporate programming into our architectural practice. So the parametric approach we used here was to make a definition of well, just look at the fins and the details. You see the details are the same if you are on top, if you are or at the sides or here. It's all the same detail. So it's really a building with one detail. but the detail is no place the same. Here it has less depth and less angle than here. So it constantly changes. And we handle this in this way. Well, look at this principe drawing, where you see these red stars. Those are the points of reference which we calculate, and we calculate the relative positions from each red star towards the next, towards each other. And we make spreadsheets, which you see here to the left, all the positions. The contractor needs to know all the different angles. These are the X and the Y positions. These are the axes, which you don't see here, it's farther to the right in the spreadsheet, are the different angles. The reference lines and points make towards each other, and the shifts. You see also that there's this piece shifts here. And all these data, which are millions of data really, are handled through databases. And what we really give to the contractor is this spreadsheet, this database, with one drawing. Well, in the end he got more, but that's the principle, and it works. You give him this one drawing, all these numbers, and he can derive from that how long, which angle, how curved, etc. all the pieces have to be, and how they are assembled together. That gives us an enormous, powerful tool, really, to handle very complex projects. As a small office, we are an office of about 6 to 10 people at its most successful stage, but the complexity is enormous. We couldn't handle it by making drawings, like we did in the old days, or like they do in Brazil for projects of Oscar Niemeyer. There you see thousands of people on the working site. We have to be more clever than that, and this is the tool we have found to catch up with our imagination. A project we are involved in right now is a commission for a sculpture in Rotterdam, which also activates its environment. It's placed in an old urban fabric, like an immigrant. There are many people from Turkey and Morocco living there. Here's another immigrant. This immigrant makes sounds when you pass by. It starts to make sounds, and then you ride it. When you go on top, like this old man is doing. This piece is a soft spot here, where there are built-in sensors. When you walk on them, you will trigger a field of light which is stretched along the whole strip, 150 meters long, and you will activate a slow wave through that grass, that lawn. And here always lose the pointer. Here is the stairs. Descending the stairs activates a huge speaker built in here, and then the sound of this periscope comes from its deepest inner mass and will swell until you reach this point. Then you will be seen by infrared beam, and it will diminish again. So this will be like, I couldn't find the videotape belonging to that project, with the sound. What we do there is sampling sounds from Turkey, and like in the Parasat project, work upon those sounds and calculate real-time new utterings of that Periscape project. So it will feel like he's talking to you when you descend the stairs. And it will feel like you play like this person here on top of it, this field of light. Like it's a huge instrument. And these images you will really see, because these lamps are dimmable, they can be bright and they can be completely dark, and we can program this. You might, this will be the last part of the lecture, you might put the other CD-ROM in the computer. It is called The Genes of Architecture. And see if that will run along with the attractor game. The attractor game is something we developed for an urban planning study in the north of Groningen. I have the program also here, but we can have a look at that later, maybe, or if someone is interested. What we really are doing is placing attractors, like these buttons here, programmed in Visual Basic, into the landscape. And these attractors we have programmed in such a way that you have these sidebars here, that they can have a certain strength and they have a certain area in which they are working, in which they are active. So some attractors are very strong in a very small area, other can be very weak attractors in a very large area. We use these attractors as a design tool to design the structures of water, the structures of the domains where people are living, these red spots, and we translate these rather intuitive shaped colors. It's just different brightnesses of colors, and it's just like painting in the landscape. We calculate. Now let's say differently, I can hang DXF blocks to different brightnesses of this painted landscape, and I can give values to these DXF blocks. I can have random values, and in the end we end up with this drawing, which is 1 kilometer from top to bottom. Then you can stop this one and try to start the Genes of Architecture CD-ROM. What we did here on the scale of the landscape is exactly the same as we did on the scale of buildings. We can paint freely, like we could shape freely the 3D models, and we can say exactly how much water there is. We know through these DXF blocks, which we can calculate upon, we can give it a certain width, height, we can give it measures, we can give it volumes, we can give it prices, we can give it anything, we can label it. So we have an exact insight in how much water in this picture is. We have an exact insight how much area these living domains for living contain. So at the same time we have this picture, which is all the paintings really we put on top of each other, of the water domains, the trees and the public zones. Then we have at the same time this picture and the exact figures for calculation. It looks like new geology. And we have it in very much detail also, because looking for that pointer again, here it is. Here you see trees. It's not just painted. These trees are a translation of these DXF blocks, so each tree is labeled here. We know exactly which coordinates these trees have. We know exactly what kind of tree it is, or we could know exactly what tree it is, how many there are, and how much they cost, and how high they are. And we know that for everything. In these domains, we inserted dividing the contour lines, freestanding houses, 2 under one roof. I'm not sure how these are called in England. Kind of small mansions, and patio dwellings, etc. We can go any step farther to make it a real new environment where nature and building is completely merged, where ecology is interpreted as a continuous stream running in between these domains for living. And people always live at the edge. People always live here, and they step in their back garden and up into this ecological stream which connects water-rich environments with forest, tree-rich environments, with drier environments here. Thank you for your attention.
Thank you, Kas. Are there any points you'd like Kas to give you further information on, or any questions or comments?
None of the sort.
I have a question about the Neotians. Is it ever going to be finished, or is it like?
I hope not.
Yeah.
Then we have work to do. But no, it's intended not to be finished, never to be finished, really. It should educate itself. There should be new layers of information each year merged into this environment. So it's what you see is really the first steps, the first environmental experiences which we have designed into. You have to merge the new layers. So we will never add new objects, but always continue the work which we started. But it gets more and more information rich, you could say. The level of information will increase.
Yeah.
That's the idea.
The sea does really come in, or?
Yes.
So the sea will bring its own influence on the...
Well, it's in an indirect way. The water you saw, the water tunnel, is collected in the bottom. There the sea level rises, but it's fake. It's a remodeling of the big sea outside. No, not really. No. We wanted to do that, but it doesn't work because if you have seawater through pipings, it corrodes and you cannot handle it. It stops after a few days and then you have nothing. So we wanted it, but we couldn't.
And how is the passage from Nox to Nederland?
You just walk through. You don't really notice, really. It's one continuous stream inside.
Weren't there 3 buildings against each other?
No, 2. Yeah.
Okay. Anybody else? Okay. Thank you very much, Kas. Nice of you to come back.
Welcome. So, quite thirsty. How much time?
Your water queue was exactly